Okay, guys, so if you'll get your notes back out, let's look at section 4.2. Section 4.2 talks about the addition rule for probability. Two events are mutually exclusive or disjoint if they cannot occur at the same time. The events have no outcomes in common. An example would be drawing a 4 of hearts or a 7 of diamonds. You can't draw that single card that would meet both of those, so those are mutually exclusive. Drawing a red card or getting a queen of hearts, you can draw a red card that is a queen of hearts, so therefore those are not mutually exclusive. Alright, if we want to find the probability of two events and they're joined with the word or, we need to add those probabilities together after we find each. If they're not mutually exclusive, we have to add, but then we have to take off the overlapping event. Okay, let's go do some problems. So let me get out of this. Alright, go ahead and get your book and turn to page 206. And let's start out and let's do number 3. Alright, number 3 says, decide whether these events are mutually exclusive. Okay. Remember now, mutually exclusive means they have no outcomes in common. So if I look at A, if I roll a die and get an even and get a number less than 3, there is one overlapping event right there. I could get a 2, which is even. So those are not mutually exclusive. Okay, because I have an outcome in common. B, rolling a die, getting a prime number, 2, 3, and 5, and getting an odd. Well, 3 and 5 are odd, so you have some outcomes in common, so these are not. Okay, C, rolling a die, getting a number greater than 3 and less than 3. There's no outcomes in common, so these are mutually exclusive. And D, selecting a student in your class, the student has blonde hair and blue eyes, so that can happen. You can have a student that has both, so those are not mutually exclusive. Okay, jump to 7. All right, we're on the next page, so we're on page 207. It says the following doctors were observed on staff at a local hospital. So we got a chart. It says choose one doctor at random. What's the probability that A, she is a pathologist? The pathology row is the top row, 6 plus 1. So I need to add those together, which is 7. Add them all together for a total of 38, and that will not reduce. Okay, B. It says he is an orthopedist or an MD. All right, now if I look at my chart, look across from orthopedist, there's 20 plus 2, which are orthopedist. Okay, or means to add. So I'm going to add the number of MDs, which is 6 plus 7 plus 20. That's going down. That's 33. But I added the number of orthopedists already, which is 20. So I have to take that off because that's an overlapping event. So this is a case of that second rule when they're not mutually exclusive. All right, if I add that, then I would get 35 out of a total of 38. Okay, let's jump to, let's see. Okay, I think 11's okay. Let's go to 17. All right, 17, that's going to be on page 208. Okay, we got a big chart right there. It says, in a recent survey, the following data were obtained in response to these questions. If the number of summer classes were increased, would you be more likely to enroll in one or more of them? If a student is selected at random, find the probability that A, there's no opinion. So I see that no opinion row going down, which is 5 plus 2, so that would be 7. Add all those people together, so freshmen and sophomores total 58 students. So 7 out of 58. All right, part B is freshmen or is against the issue. So if I add up the number of freshmen, I'm going to add 15, 8, and 5. That adds to, I don't know, or is against it. Okay, so that means they voted no, but we have to take off that overlapping event of those 8 freshmen. So that should add the 32. We reduce that into 16 over 29. Okay, and C says that is a sophomore and favors the issue. That means that they're a sophomore that said yes, and there's 24 of those. So and means that it's going to be somebody that does both. They fit both categories, and that reduces to 12 29s. All right, let's see if we can finish out this section with number 23. This is talking about some dice again. Some cards. All right, 23A says, if one card is drawn from an ordinary deck of cards, find the probability of getting a queen, a king, or a jack. Well, there's 4 of each. So that's going to be 12 out of 52 cards, which reduces to 3/13. Okay, 23B says a club or a heart or a spade. There's 13 of each. So that's 39 out of 52, which reduces to 3/4. Okay, C says a king or a queen or a diamond. Well, there's 4 kings, there's 4 queens, there's 13 diamonds, but we've already taken into account 2 of those when we added up the kings and queens. So if I add those together, I would get 19 out of 52. Okay, D says an ace, which is 4 of those, or a diamond, there's 13 of those, or a heart, there's 13 of those. But now we've got an overlapping event of 2 because we've counted the ace that was a diamond and the ace that was a heart, so we have to take that off. So that's 28 out of 52, which is 7/13. All right, and the last one, E, says a 9. There's 4 of those. There's 4 tens. There's 13 spades. And there's 13 clubs. But we have 4 overlapping events because we have counted the 9s that are spades and 9s that are clubs. So that's 2 cards. The 10 that's a spade and the 10 that's a club, which is another card, which is a total of 4. That is 30 out of 52, which is 15/26. All right, shoot me a message if you need some help.